Okay, so at the very beginning of class, I gave the kids a challenge. There were 3 strings in a triangle, and I did not tell them anything other than here is a tape measure, and I want you to figure out for me what angles they are. And those 3 strings are in a kind of a strange orientation in the room. They're not like laying on the floor. There's one on near the ceiling, there's one on my desk, there's one on the floor. So what the kids figured out was that they needed to figure out how long each side was. Once they knew how long each side was, what did you guys do again? Law of cosines. Law of cosines was the first thing you would do, and I don't know, did anybody think about, like once you figured out this was about 50, I'm going to round it to 54 degrees, did anybody figure out that you don't need to use the law of cosines to find the next one? What did you use for the next one then? Law of sines, because you have an angle on the side across from it. So law of sines then can be used to find this and this. And of course, the last one you just got to say, oh, it adds up to 180. So the last one becomes, by default, the answer. Okay, so that was just a reminder that if you have all the sides, law of cosine is pretty handy. All right, take a look at this one for a moment. I have purposely named it without a C in it. It's got Q, R, and S. So my question for you is twofold. Number one, is this set up well for law of sines? No, because it doesn't have a side and the angle across from it. Is it set up well for the law of cosines? Yes, except for one little thing. If you're going to do the law of cosines, at some point at the end of it, it's going to say cosine C. Do you get that what letters are up there are almost irrelevant? You get to pick what C is going to be? All right, so we would choose the Q to be the C in this case. Would you please just take a moment and figure out for me, how long is this side? The question mark, the black question mark side. RS, you could say. I'll pause while you figure that. Okay, let's see if we have consensus here. It's a big, long, scary formula. A squared plus B squared minus 2AB cosine C. That's why we call it the law of cosines. Don't forget it equals C squared. So at the end, you better pick a square root to get the final answer. And what did you get? 6.4. Who can verify 6.4? Okay, good. Lots of people. Solved. Got the C was 50. That's a 50. So we were solving in that case for the thing across from the C, which would be that. And so you took a square root at the end. 6.4. All right. Now, do you get that I still don't have the height, and therefore finding the area of this thing would be a bit of a pain? Don't you normally need the area? 1/2 base times height. Does that ring a bell? All right. But you could figure out H pretty easily, but you don't have to. There's an app for that. There's a formula for that. That doesn't need the height. Does anybody have it memorized? All right. This will be a little thing that can help you on your ACT or your PSAT to become a National Merit Scholar and get your college paid for. All righty? 1/2 AB sine C. Now again, there is no C up here. We have to decide what C is. So if, logically, they have A, B, and sine C, there's only one way that can go. I want you to think about that for a moment. Let's say I didn't have any lengths of sides. I didn't even label any of the letters. And I have 4 and 3, and let's say, actually that's not, if that's 4, the other one's got to be like 6, and let's say this is like 25 degrees. How on earth do you figure out what goes where? Yes, what are you thinking? 1/2 AB sine C. What are you going to do? Yep. A can be picked as 6, did you say? Okay, you want that to be A? All right, and then? Oh, so you really should start with the C has to be the angle. Okay, so if that's C, then what has to be A and B? That can't be A, right? Okay, so that and that have to be the ones you have. What I'm trying to say is, Ignore even what their sides, lengths, and their angles are. If that's the angle you have, do you get the little c has to be here, and that makes this A and B, and it doesn't matter which one's which? But you have to have a side angle side situation, or you can't do it. So let's go back to this problem. Did I give you a side angle side situation? No, I did not. But could you figure out how long this side is using some other form of magic? Yes, because it's got a side and the angle across from it, so law of sines. And then once you had this side, then you could do it. All right, so I just want to point out that you have to have a side angle side. Did I give you a side angle side in this scenario? Yes, I did. And therefore, you can use that new formula I just taught you, kind of pre-teaching what I'm going to be teaching you on Monday. Okay, so just take a moment, figure out what that answer is. 1/2 AB sine C. I'm going to put in the numbers 1/2 A and B. I'm going to pick A to be 7 and B to be 8. It doesn't matter. It could have been 8 and then a 7. Doesn't matter. And then sine 50. Is that what you guys put in? Good. Then you got it right. So now here's the question. Do you get, if I wanted to, I could have figured out that blue height there and then just done it the old-fashioned way. 1/2 base times height. Get what I'm saying? I just need to find the height, and then I got the base. If I had the height, I could be able to do that. So just let me show you what happens if I do that. To find the height, everybody, right now, find H using trig. You've got a right triangle. Find H using trig. Don't just stare at the board. You've got to be writing, otherwise it doesn't count. Find H using trig. If I'm using the 50, should I use sine, cosine, or tangent? Sine of 50 is opposite over hypotenuse. The opposite's H, hypotenuse is 7. There we go. So instead of actually getting the answer with a decimal, I'm going to leave it as an exact answer and multiply both sides by 7 now. And then I'd say H is actually equal to 7 times sine 50. Now I just want you to ponder that for a moment. Do you get how 7 times sine 50 is part of my answer? So this formula just takes advantage of the fact that you could always figure out H and then do it with 1/2 base times height. It's basically just 1/2 the base, which is that and that. And the height is just 7 times sine 50, see? So that's what that formula is really doing. It's just forcing you to find that angle really fast. And if you just memorize 1/2 AB sine C, imagine a scenario where they say A, B, C, and it's going to be really hard to figure out that height. But you got this, and you got this, and you got that. What could you do? 1/2 AB sine C. Now, if you forget that, it's not that much slower to just figure that out using trig. Okay, but this is a typical scenario where you could see an ACT question where if you knew a formula like that, you could use it. Now, they won't officially say you have to know 1/2 AB sine C in the standards for the ACT, because you could solve it by using right triangles. It's just way faster if you know that sneaky little formula. Okay, so enough about that. That's just a little bit of a preview of what is coming Friday. So I've been trying to get across to you when to use law of sines and when to use law of cosines. So the last frontier here is we did that ambiguous case where it could go this way and it could go that way. Remember what I'm talking about? I'm going to do a 2-second review on that. Let's say this side here is 8, this side here is 8, this side here is 10, and this angle here, actually it looks more like the side's 12, sorry. And then this angle here is about 40 degrees. So my question is, how big's that? I'll pause for a minute while you try that one. Okay, so I had somebody say we could set up law of sines here and say 8 over sine of 40 goes with 12 over sine of x, and we can find that angle. And what did you get?
I got 74.6.
All right, 74.6. Can anybody verify that number? Ooh, a lot of people. So if that is 74.6 in there, 74.6 degrees, then this one must be 74.6 degrees. And can't I just jump right to finding this last side? Sure, because I know this angle right there has to be 180 minus 74 minus 74. What'd you get? 30.8. Can anybody verify 30.8? Okay, good. And if that's 30.8, law of sines again, go ahead. Yes.
Sine 8 over
8 over sine 74.6 would go with, we can call it y, okay, y over, you got it. I just wanted to talk over the setup of that, and how many of you think you could have done that? Okay. All right, so now, 2-second review of bearings. If I say east, but 20 degrees north, draw a little arrow where you think I mean. Head east, but 20 degrees north. Would you agree that I just sent you that way? Raise your hand if you had that one right. Okay, what is it in true? True means you head straight north is 0, right? So then, whoop, what's that? So it'd be 70 degrees true. All right. Then, if I had you from here, head directly southeast. Southeast from there. Do you get that that just made a 45-degree angle from there? That's where southeast would be. Do you get now that I could figure out every angle in this little cluster? Take a moment and figure them out. It's not too tough. If that's 45, this must be 45, right? And this is a 90, and this is a 90. Those are all no-brainers. So then we're just left with those two. Who's got an idea how we could do that? Yes, sir.
Like 20 and 70.
That 20 and that 70 is the key. So tell me about the 20. Where can it go?
Oh, it can go to the other side of the building.
All right, I'll show you why. If I take this, it's supposed to be a straight line. And another one. These are parallel lines. And let's move it down just a smidge. Then that's a transversal cutting across here. And so if this is 20, then that's got to be 20 right there. And if that's 20, then that's got to be 70. All right, just wanted to kind of remind you a smidge about bearings. So now you have a little in-class quiz. Most people got 5 out of 5, but there was about 5 or 6 or 7 kids who got like 2 points out of 5 because they screwed up their angles. So be careful with your angles. And wait, don't put your iPads away because it's actually going to be up on the screen. Okay, you can use paper if you want, but I'm just putting the problem up on the screen. All right, so here's, let me pause for a second while I get this prepared. Okay, so this is One thing that some people had off in their mind as far as geography goes, Minneapolis-St. Paul is kind of north, so I put it as my dot near the top, okay? Then we're going to head to Fort Myers. Do you guys get that that is south and east, and it's generally like this FMY down in the corner there? That's the route you'd take to go to Fort Myers. Then do you get that Phoenix is actually north of Fort Myers? It's north and definitely way to the west. So you want to kind of get that set up, because I had some kids getting all confused because they were trying to put the dot, like you see this dot that's in between MSP and FMY. They're trying to put it like there, like Phoenix and Fort Myers are like at the same latitude as each other, and they're not. The thing gets all screwed up if you do that. So start with them in the right general places, and now you definitely want to use your compass roses and everything. Make this all perfect, because you're going to be graded on actually 3 points for the work and then 2 points for the answer, making a total of 5 points. So the work means you got to show me all the angles, just like we just did in class. And then the answer is 2 of the sides. So when it's all done, you'll know all the angles and all the sides. Make sure you show your work and get partial credit at least that way. All right, I'll pause while you work on that. Talk through just the first one for those of you that are learning about bearings. So I'm going to pause for a second. Okay, as I go from MSP down to Fort Myers, I know that it says to go 63 degrees this way. If that's 63 degrees, then this one must be 20 what? 27. Now, you don't have to check that yet. It also says we're going to go this way, 43 degrees, which means that this part must be 47. That means together, that must be 74 degrees at the top. Raise your hand if your person had that right. Okay, that's one of your points. All right. Now, actually, you don't technically have to find all 3 angles to be able to do this problem, so I'm okay with them having 2 of these 3, but 73 and 33 were the remaining 2 angles. 73, and 33. Now, that's 2 of your points are having the angles right. Okay, if they got 2 of them right, you get 2 points. 1 point is for generally setting it up where they have a compass rose at each corner, and they have the lower right-hand corner is the furthest south. That's just generally, did they get the triangle right? That's kind of a free point, as long as they didn't disobey the directions. And if they made these the same level, like they're both, like this one's up here or something, then they'll lose that point. But I told them that the Fort Myers is further south. All right. Then last but not least, they were given 2,000 here, so hopefully you know enough to go, oh, I got a side and an angle across from it. That's law of sines. And therefore, final answer is 1133 and 1990. If they're off by 1 in either direction, I'm okay with that. All right, so there's 2 points for the answers, which are these 2 are technically the answers. 1 point for each of those. 2 points for the angles, as long as they have 2 out of these 3 right. They'll get 2 points for that. And 1 was this general setup. That gives a total of 5 points. Get a score out of 5 on the top and a CB in your name near where you put the score. Yes? If they do have the angles wrong, I realize they're going to get the whole rest of the problem wrong, and yes, you just give them what they earned. If they get 1 out of 5, I know it sucks to have that happen, but they need to know that they goofed it up. All right, get back to your spots. Okay, so we're wrapping up for this hour. The test at this point is looking like it is approximately 4 class days away. We got a couple days left on finding areas of triangles, and I gave you a preview of that today. Main thing you guys should be working on finishing up is that lab, and that's all I have for the video for